Hello everyone. Today I'm going to give a small demonstration of some simulation uh, user walking through the path, which might help you to understand how these digital twins uh, uh, assist in network planners and operators in practice. Before jump onto that, I want to quick recap on my earlier presentations. I discussed the concept of in my earlier presentations. I discussed the concept of digital twin representation of foliage using computer vision and image analysis techniques. The focus has been on digital twins can be built using computer vision and uh, uh, image analysis for key environmental elements such as foliage, buildings, street furniture using aerial and street view imagery. These digital twins serve as a powerful tools for wireless network planners and operators. By integrating these digital twins into ray tracing analyzers, the wireless network operators or wireless network planners can better understand the physical and environment dynamics, identify optimal node placement locations, determine the number of nodes required to ensure the strong connectivity and high user data rates, estimate deployment cost and more accurately and balance cost versus performance before the actual rollouts. If you want to get into my previous presentation, here I'm providing a quick link on the top right hand side corner. You can understand, you can take a look at and to understand how the digital twins can be built for those key elements like foliage, buildings, or any other street furniture. Now I would like to walk you through a simulation that demonstrates how these digital twins assist network planners and operators in practice. Again, for this study, I selected a region of Philadelphia downtown where I built a foliage-based digital twin model. Using that model, and then based on the municipality data for the street light information, by feeding all this information, it came out saying that maybe 20 nodes are sufficient to serve the region. For the user path simulation, I selected a sub-region in the region that I have selected, and then I'm going to use only like a 5 to 6 nodes to demonstrate this. When the user travels through this the selected path, how he moves from one node to other node. Probably we'll see that in the simulation. So this is the blue lines indicates the street light information, which has been used in identifying the locations for node placement. And then the digital twin, the model identified this foliage information, which is the 3D representation of the polygon. You can see multiple polygons, which is the 3D representation of the foliage information, which is used in understanding how the rays gets attenuated, or and then based on that information, the 20 nodes have been selected, which is sufficient to better serve the region. And then what do you call? I'm going to use only like few subset of those selected nodes. So basically, the pink line is my user path that I'm going to demonstrate today. And just for the convenience, I place the user traffic along that path. And there you can see that there are like multiple radio nodes, and then the blue cursor, as it moves along this path, you'll notice that how he is going to hop from one node to other node, and you'll also notice each tower ID gets updated. Radio tower ID gets updated when he moves from one node to other node. As the user moves along the path, the device connects to the nearest node. When the user moves away from the one node and gets closer to another one, the connection seamlessly hops from one node to the next. This transition can be visualized in real time by observing the change in the tower ID. That's change in the tower ID associated with the user's device. So let's hop on. Let's look into the simulation. On the left hand side, you can see that the user has been moving from this node, and now it's hopped onto the. I started with the 223781, moved to 224484. Now it's on 223925. Now it's on 223932. Then 223932, and then 223933. On the right hand side shows the a little bit of more of a top view, how user is moving along the user path. And also you will notice a similar kind of radio tower gets updated when he moves from one node to other node. Just to give some more information, the lines raised here shows that how these towers, radio towers, are covered the region. So basically, it helps. The visual demonstration clearly shows how digital twin helps network planners visualize area-wide coverage in advance, identify coverage gaps or overlaps, experiment with adding removing nodes to optimize the coverage and cost, strategically combine legacy infrastructure, like if there is an existing infrastructure from the previous technologies like 2G, 3G, or 4G, how we can combine that with the new technologies like a mmWave or 5G, 6G for maximum efficiency. Overall, the simulation highlights the practical value of digital twins in bridging the gap between the theoretical planning and the real-world deployment. By leveraging these models, operators can make data-driven decisions that ensure better user connectivity, improved service quality, and cost-effective deployment. Yeah, that's pretty much I have for you today to share. If you have any further questions, feel free to drop me a note. I should be able to respond, get back to you. Thanks very much. Thank you again.